So hi everyone, I'm Victoria. I'm a physiology student and recovering Excel user at the University of Auckland. And I'd like to do a bit of show and tell with data visualization and physiology with R. So today we'll be looking at some sleep and brain activity where we take continuous brainwave recordings from a pregnant woman in late gestation overnight while she sleeps, and we categorize them into discrete states. We've got a wake state, a rapid eye movement or REM sleep state, and 3 different stages of non-REM sleeps. So non-REM sleep, and in particular the stage 3 non-REM sleep, is known as restorative slow wave sleep, where you might dream but you're not going to remember it. And in REM sleep, the brain's really active. It looks a lot like you're awake, and that's where your crazy, colorful, surreal dreaming happens. And if you go through all of the stages of sleep, that's called one sleep cycle. The figure down the bottom here is a hypnogram, and it's a very informative graphic if you're only looking at one participant. But say you've got 160 pregnant women, and you want to look at their sleep, and if we plot them all at once, we succumb to overplotting. We end up with a tangled spaghetti mess, which is only representative of how my insides feel talking to a big room. So let's revise that. In healthcare and in epidemiology, a lot of that kind of data ends up summarized as 3 lines in a table somewhere. But because our sleep state data is now longitudinal and categorical, we can represent a hypnogram as a color-coded line, and the different colors will represent different sleep states. And if we, that's pretty straightforward in R. And if we plot 160 of these together, first of all, we switch color palettes so we don't hurt our eyes, but we end up with a kind of heat map, or lasagna plot if you're being cute. And okay, it's still kind of messy as it is. But if we sort these by the time that our women turn the lights out, we get something that looks like this. And now, not only can we identify from the white lines that some people probably took off their recording equipment, we can see that there's a lot of purple. And that's the slow wave restorative non-REM sleep, and that's all in the beginning of the night sleep, and that for the most part, it's in the first cycle. And that's good, that's kind of what we'd expect. In healthy non-pregnant sleep, most of the slow wave sleep happens earlier in the night. And most of the REM happens in the second half of the night, but we can't really tell that from here. So if we sort by time of night, we lose the individual participant level of information, but we can more easily see that, yeah, most of the slow wave sleep happens in the first half of the night. And while a large part of that REM sleep happens in the second half, that's the dark pink down the bottom there, there's a not insignificant amount of REM in the first half either. 2. So why might that be? Okay, let's see if it's a function of sleep length. If we sort our original sleep architecture plot by length of sleep period, it's still pretty difficult to tell. But if we now sort this within a participant row, we lose the temporal information, but we get an idea of the amount of sleep stage for each individual. Here I've sorted it so that REM is the dark pink on the far right, and we can see that generally the proportion of REM sleep is fairly similar for most women. So that says it doesn't matter how little you sleep, you have to have colorful dreams. REM is a non-negotiable aspect of sleep. And where we've got that intrusion into the REM proportion, those individuals have really long wake, large amounts of wake. And so that might indicate that they were struggling to sleep with a whole bunch of wires on their head. So we'd need to go back and have a look at measurement effects. If we sort so that the restorative slow wave sleep is on the far right, we get a different story. The proportion is really different for different individuals, and we can see it's not immediately related to the length of sleep, nor to the amount of REM that we're getting, as we see above. So given that a lack of this kind of sleep is linked with some mood disorders, we might now want to go and look at other aspects of well-being in these women who don't have a lot of slow wave sleep. Okay, so you made some heat maps and you did some sorting. It's hardly new. It's very simple to do in R. But that's kind of the point. This data has all kinds of stories to tell, but you'd never know because most of it looks like this. And while tables have their place, the same kind of data, when you present it like this, in addition to being unintuitive and a literal snooze fest, is not nearly as compelling or helpful in generating new hypotheses. I think graphics are a much better way to do this, and R is perfectly placed to help with this. I think some people will talk about a learning curve, but I think we can see from today you don't need to be super fancy to be useful. I think the takeaway here is that there's definitely room to spread the good gospel of good data visualization with R, and that we should all be dreaming in color with it. Thanks. Oh, okay. Wait for the end? Okay.
Okay, I assume the microphone's working, so does clicker work? Yes, okay. So this is actually a bit of a misleading title for a talk because I'm not actually going to tell you anything about tweets about Donald Trump. It's more of my story of actually trying to get tweet data and analyze it because it's a bit of a hassle. So first question is, what's the motivation? Why am I even looking at Trump tweets? Well, Donald Trump is the president of the United States, and a lot of his term was kind of influenced heavily by Twitter, like Covfefe, right? We kind of all know that. And you can actually, if you look back at his tweets, which is kind of to get historical stuff, but if you look back, you can see that there's a clear line between when he was talking about his beauty pageants, his businesses on Twitter, to when he was criticizing Obama and starting his presidential campaign. So Twitter and Donald Trump are kind of quite an interesting place. Is also Twitter, you can just get any data where people mention Donald Trump. So tracking that conversation should track the news. So we can hopefully get this kind of random noise that's been put together and extract some real kind of stories of humanity through it. It's also highly biased. And a tweet's quite short, so it's hard to express nuance, which means hopefully it should be easy to run some kind of text classifier on this data to get some insights, which is good. Why tweets? Well, tweets are pretty rich. So text data, tabular data, geospatial, like about if you can choose to add your GPS coordinates to your Twitter data. So some people have that. It's time series, it changes over time, it's all time stamped. Graph data, you can see like relationship between users and stuff. So it really kind of spans most forms of modern analysis, and it's also high volume and easily accessible. So you can get about 50,000 rows every hour for free. You do have to jump through a bit of a hoop to get it. You need to sign up for a Twitter developers account and apply for API access. That's pretty straightforward, doesn't cost you anything. But the free-tier API limits you to tweets from the last 7 days. But you can get quite a lot in that last 7 days. So if you want to analyze tweets over a large period of time, you need to query them continuously over a large piece of time. There are a few packages in R to get tweet data. The current one to use is RTweet. That's actually managed today and works pretty well. So the first thing I did to build this, I built a basic kind of bit of infrastructure. It was the first time I'd ever built anything. So I just went ahead and took an AWS RDS instance, which is the relational database instance, and put Postgres on that. So that was my database because I'd used it before. And then I set up an AWS EC2 instance with Ubuntu on top of that, and then it ran my compute in cron jobs in R, and then built a display in Shiny, running Shiny server on the little box. But that was fairly easy to use, and I could just take the code I'd written on my desktop and port that across to the server. And I didn't have to like build any machines myself. I could just set them up. But the downside is the cost. I was using paying for way more compute than I need, because you're paying for uptime of the computer, not what you're actually using. And there are things in R where you need quite a large computer to get it running in the first place. So you get these quite bursty workflows. So I went and redesigned it. And serverless was kind of the thing that I discovered that would be good. You don't need to, serverless compute is, you don't kind of rent a server, you just buy computers required. So it's good for these bursty jobs that we get in data science when you're running like a script to process a batch of data. And an interesting kind of point is they're basically infinitely parallelizable. Like if you've got something that you're running a job over and over again, you want to run 1,000 of them. Well, with serverless, you can sort of run like 1,000 at once. Which is an interesting way of like compressing time, which is cool. There are several options available on AWS, including Lambdas and Docker. I tried Lambdas, it wasn't fun. There are a couple of projects who've got it running on R, but basically you need to get your code to run on AWS Linux, and AWS Linux does not support, it doesn't have good support for R, so it's not really advisable. So the other option was Docker. I spoke to people in the community and they said Docker. It's pretty easy to use if you're comfortable with Linux, and there's an R project called Rocker that makes things easy to work with R and Docker. Rocker also has the Ubuntu image, which means I could just take the scripts, instructions I'd use to set up my EC2 instance, and put that in the Docker file. So I basically just copied and pasted some code, pressed build, and it ran locally. And then once you've got it running locally, you can just deploy that fairly easily to AWS using ECS and Fargate. You can set up scheduled tasks for that. So every 20 minutes runs a thing. And I did some analysis the other day, and once I did a bit of optimization to bring down the compute time and the memory usage and get it all running well, my compute costs have decreased by 90%, so an order of magnitude, which means that this thing runs for sense. The next steps, I'd like to kind of share this with other people. The Docker files, you can just push and pull from a repository. So with a bit of work, anyone can basically point the Docker file at their own database and Twitter and pass their own search query in, and you set it up as a cron job, and they'll be able to get the data as they want it. I'd like to add more analysis and visualizations for the front end in Shiny. And build some classifiers. So ideally, I think it would be fun to build a model which distinguishes between like liberal and conservative tweets, and then label my whole data set with that. So I've got 15 million tweets taking up like 15 gigabytes. So I can't really label them all myself, but I could do a few hundred, build a model, classify the whole lot, and then display that on a map. So there's some interesting things like that I'd like to do. And I'd also like to take the storage serverless, because that's costing quite a bit more than the compute. And yeah, that's kind of the next steps of the project. So it's an interesting kind of story in actually getting R to work for you. Instead of having to run things, you can just have stuff running in the background, which I think it makes me interested anyway, or I'm interested in it. If you want to learn more or like see the actual project, I'm available on these platforms, and I will be sharing more of my story as I move forward. But thank you.